Very welcome in your own chemistry class. We are studying electrochemistry. This is the last video of this chapter. In this video we will discuss about the corrosion. To explain the mechanism and types and the prevention of the corrosion, we will take the example the rusting of iron. First of all, we have to understand what is the meaning of term corrosion. Corrosion, what is this? This is the process of deterioration of metals by the environmental factors like chlorine gas, SO2 gas, carbon dioxide gas, oxygen gas, moisture, HCl gas, etc. into unwanted metal oxides or hydroxides or carbonates. This complete process is called corrosion. Okay, it is the opposite process of metal extraction. Means in metal extraction we take some ores. Ores means the matter which is derived from the mines to obtain pure metals. Ores are generally hydroxides, carbonates, sulfides, etc. any compound, and by the extraction process we obtain the pure metal from the compounds. For example, we take sodium from sodium chloride, we take Fe from Fe2O3, this is hematite, we will take Ag from AgCl. These are the ores and these are the pure metals. The obtaining of pure metals from the minerals or ores is known as the metal extraction. But in corrosion, the pure metal, this pure metal is converted into any compound like oxide or hydroxide or carbonates or etc. Okay, the example of this is rusting of iron. We know that about 15% of total production of iron in the world is lost due to corrosion. As we have seen in the rainy days, when moisture is very much in the atmosphere or due to rains the water is collected on the iron objects we will use in our homes or waste iron articles, we see that some reddish brown powder is deposited on the surface of the iron objects. That reddish brown powder is rust of iron. Okay, so this we will take the example of rusting of iron. First of all, we will discuss about the types of the corrosion. Corrosion is of two types. First, dry or chemical corrosion. Dry or chemical corrosion means the corrosion takes place in dry conditions. Dry condition means in the absence of moisture or water. This is caused in dry conditions due to atmospheric HCl, SO2, Cl2, H2S gas, etc. This is the dry, only oxidation reduction or redox reaction takes place. The second one is electrochemical corrosion. We are studying electrochemistry, so the topic to discuss here it is the electrochemical corrosion, or we can say it is wet corrosion. Wet corrosion means it takes place in the wet condition, or we can say in the presence of moisture or water. This is caused in the wet conditions, that is in the presence of moisture and atmospheric O2 and CO2. The rate of corrosion, this process depend upon the metal. When surface of metal is rough, we have seen in our homes that the smooth surfaced iron projects get corroded in very slower speed. But if the surface of iron is rough, then their corrosion takes place in very fast speed. So because at the rough surface water or moisture can be collected easily. So surface of metal is rough, then corrosion takes place in fast speed. Impurities are present in metal. Because presence of impurity, the activity of metal is increased. Okay, and metal is more reactive. More reactive will be the metal, the speed of corrosion will be high. So these important three conditions in which the corrosion of metal takes place in high speed. Okay, now we will take example the rusting of iron. Clear here? Okay. Yes, mechanism of electrochemical corrosion, or we will take in the example rusting of iron. So we can say the mechanism of rusting of iron. The mechanism of electrochemical corrosion can be understood by the taking example of rusting of iron. Rusting of iron is a electrochemical reaction. It is very important question for this year, that explain the rusting of iron is a electrochemical process, or we can say electrochemical phenomenon. How? So we will take complete derivation of this type. So understand, this is the any iron object. The surface of iron object here is rough. Any water droplet is collected on the rough surface of the iron object. Okay, CO2, carbon dioxide, atmospheric carbon dioxide is dissolved in the water. This water droplet acts here as an electrolyte. The atmospheric oxygen O2 gas acts here as an cathode, and the iron objects acts as anode. This is the small electrochemical cell. Okay, anode is the iron object, cathode is the atmospheric oxygen gas, and electrolyte is the moisture or water in which CO2 or HCl or SO2 or any acidic gas is dissolved. Okay, so see, water drops containing dissolved CO2 form a thin layer on iron surface and acts as electrolyte. Okay, iron surface and O2 gas acts as anode and cathode respectively. Thus a small electrochemical cell is formed on the surface of iron. Okay, this is a small or tiny electrochemical cell. Okay, now what are the reactions which are taking place in the corrosion? Okay, see, in electrolyte, first of all H2O is mixed with CO2, or we can say CO2 is dissolved in the H2O, and H2CO3 means carbonic acid is formed, and carbonic acid is dissociated as 2H plus and CO3 minus 2. So H plus ions are obtained here. Okay, we know at anode oxidation reaction takes place. So Fe means iron atoms are oxidized into Fe plus 2 ions. Okay, we are taking 2 Fe plus to balance the reaction, are oxidized into Fe plus 2 and releasing electron. This is oxidation half reaction. At cathode reduction half reaction takes place. So H plus ions, these H plus ions and atmospheric O2 gas gain the electrons, these electrons, to make H2O. These electrons are taken by these H plus ions. So 4 H plus ions takes 4 electrons plus O2, this is atmospheric O2 gas, and forms H2O liquid. It is in liquid form. This is reduction half reaction. So net cell reaction will be the combination of the OHR and LHR. So 2Fe plus 4H plus O2. Okay, 4 electrons are cancelled by 4 electrons is equal to 2Fe plus 2 plus 2H2O. This is the net cell reaction taking place in the corrosion process of the iron surface. Okay, clear? Now Fe is oxidized into Fe plus 2, but the reaction is not stopped here. This Fe plus 2 ion is oxidized into Fe plus 3 ions by atmospheric O2. Okay, thus Fe plus 2 ions are formed in the reaction, get oxidized into Fe plus 3 ions by atmospheric O2, and Fe2O3 is formed. Okay, this Fe2O3 is hydrated by atmospheric moisture, or H2 is forming here also. By hydrating Fe2O3, the rust is formed. This Fe2O3 is hydrated by atmospheric moisture at the surface of Fe, and thus Fe2O3.xH2O, a reddish brown powder, is formed. This is known as the rust. For Fe plus 2 ions, these Fe plus 2 ions plus O2, atmospheric O2 plus H2O, this H2O will absorb in Fe2O3 is formed, and this Fe2O3 absorbs XH2O to make Fe2O3.xH2O. Actually this is the rust. Okay, now what is the formula of rust? It is Fe2O3.xH2O. It is also very important question for board exam. Give the formula of rust of iron. Fe2O3 dot SH2O, where X can be 2 or 3. Okay, this is the complete process of corrosion of iron. Okay, see. So see the summary of the corrosion of iron. Due to dissolved CO2, water layers act as an electrolyte. H plus and CO3 minus ions are obtained. It is the iron surface. It is the water droplet, and CO2 is these ions are present in this electrolyte. O2 gets act as cathode, and Fe object acts as anode, and rust is formed on the surface of iron. Rust means Fe2O3 dot XH2O. Clear? Okay. Now we will discuss the method to prevent the corrosion. It is very harmful process where there is very great loss of iron in the world due to corrosion. So for number one is barrier protection. Barrier protection means we will use a barrier between the iron and the atmospheric oxygen and moisture to prevent the formation of a small galvanic cell. If galvanic cell is not formed, then corrosion will not take place. So see, the surface of coated with paint. We use generally the iron doors and windows are painted with red oxide. Okay, or any red oxide, any paint. Okay, or we can apply the thin film of oil or grease on Fe surface. Generally in utensils we use oily or greasy surface layer to prevent the corrosion on the iron objects, just like pans, iron pans. Okay, so the surface is coated with paint. Applying the thin film of oil or grease on the Fe surface, the coating of red oxide on the Fe surface, or by waterproof packing of Fe parts to prevent the formation of the tiny galvanic cells. These are the barrier protection. The second one, sacrificial protection, is very important. Very important protection, sacrificial protection, or we can say galvanization. It is very important. In this method, Fe surface is coated with any other metal which is more reactive than the iron. Okay, so in this method, Fe surface is coated with any more electropositive metal like Zn. In this way, Fe does not come in contact with the water or air. Thus, oxidation of it doesn't take place and iron not be rusted. But the more active metal like Zn undergoes corrosion. Why? Because the Zn comes in contact with the atmospheric oxygen or the water moisture. So in the place of Fe, Zn undergo corrosion and changed into its rust, means ZnCO3 dot ZnOH whole twice, means Zn zinc carbonate and zinc hydroxide. The Fe is protected by covering its surface by Zn. This process is called galvanization. Actually, galvanization is the process in which a coating of any more electropositive metal is made on the surface of iron. This process is known as galvanization, and the iron at which galvanization takes place, the iron is known as the galvanized iron also. So due to this galvanization, zinc got corrosion, while due to the sacrifice of the Zn, Fe is protected from the corrosion. If some scratches occur on the galvanized iron, even then iron will not be rusted. Means Zn sacrifices itself to protect the Fe from the corrosion. So this process is termed as the sacrificial protection. Okay, Zn sacrifices and iron is protected. Okay, and the third and last very important method to prevent the corrosion is the electrical protection. This is used to prevent the bottom of ships and underground water pipelines and tanks from the rusting of iron or from the corrosion. In this methods, rod of more active metals like magnesium, zinc or aluminium are connected with Fe articles or iron articles. These rods act as anode and prevent the oxidation of the Fe 2 into Fe plus 2, and hence corrosion is prevented. See, what is this process? Suppose this is the underground pipeline. Underground pipelines means anytime these are in the contact of moisture, moisture is always present in the soil, or ships are always present in the water. Okay, so moisture, there is no any prevention in the contact of the moisture and the iron particles or iron articles. So there is always a galvanic cell is present or formed. So if these underground pipelines or bottoms of the ships are connected with any rod of any more active metal like magnesium, zinc or aluminium, then this more active metal acts as anode. We have studied in the electrochemical series, more electropositive metal always act as anode. So Mg or Zn or Al rod acts as anode, so Fe should be act as cathode. Okay, so at anode oxidation will take place and electrons are released. These electrons reached to the iron article by the wire, and if here Fe plus 2 ions are formed, then these Fe plus 2 ions are reduced into Fe. So the corrosion is protected. Okay, corrosion is prevented. Magnesium blocks are attached in the bottom of the ships or pipelines to prevent corrosion. Okay, these are anodes which are using to prevent the corrosion. So this process is called as the electrical protection. Okay, some very important question related to corrosion are: what do you understand by the galvanization of iron, and what are the uses of galvanized iron? Then question number 1, write the chemical reactions taking place in the rusting of the iron in acidic medium. We have discussed about this process in this video already. Explain that rusting of iron is an electrochemical process. Write the name of two metals used for electrical or anodic protection from rusting of iron. In anodic or electrical protection is also called as the anodic protection, because anodes are used to prevent the corrosion. Okay, I have told you that magnesium, zinc or aluminum can be used as the anode to prevent the corrosion. These are the most important questions related to corrosion. You have to write the answers of these questions. If you have any problem, you can ask me in the comment box. Okay, thank you.